Welcome everyone. For today's prep, we're going to be looking at the first derivative test. So this is kind of review from things we've seen already, and we're just kind of putting the pieces all together. So what we're going to look at here is how to find and then classify the critical numbers of our function using the first derivative. So first, let's review over how do we actually find the critical numbers and what these critical numbers are. So we say that the number x equals c is a critical number of our function f, provided one of two things happens. Either the derivative is 0 there, or the derivative does not exist. And the reason why we're interested in these numbers is because of this result right here called Fermat's theorem. And what this says is that if our function f has a local max or a local min at some number x equals c, then either one of those two things has to happen. The derivative is 0 there, or the derivative does not exist there. So what this is telling us is that these critical numbers are the possible locations for a max or a min. So these are just the possible locations where our function has a max or a min. So the key word there is possible. Doesn't necessarily mean we're definitely going to have a max or a min at a critical number. But if our function does have a max or a min, it has to happen at one of these spots. All right, so we've looked at how to find these places where the derivative is 0, where it doesn't exist. Now, once we find them, how do we know for certain whether we have a max, min, or maybe neither? And that's where our first derivative test comes in. So once we've located our critical number, then we want to look at our sign chart for f prime. So we're going to, just like we do with finding the intervals of increase decrease, we're going to get our sign chart for f prime. And then we want to see if it switches signs at our critical number. So if we go from positive to negative, then our function has a local max. And if we go from negative to positive on our sign chart, then the original function has a local min. And if it doesn't switch signs, well, then our original function doesn't have a max or a min. So a lot of times we call this as neither. It's neither max nor min at that critical number. All right, so how do we remember this? Really, the best way to remember this test is to just draw a rough sketch of what the function's going to look like. So we're just going to draw a sketch of f, just as a way to remember this test. So it's kind of hard to, it's hard to remember. Positive to negative, what's going on there? Just draw a picture and it'll be easier. So let's try an example. And I want to jump down to the second one here. All right, so we're going to find the local max and min values for this function. So the function here is 1/3 x cubed minus 2x squared plus 3x plus 1. So the first step is we got to find our critical numbers. And once we find them, then we're going to classify them. All right, so how do we get our critical numbers? Well, this is where we use our first derivative. So we're going to calculate f prime. Differentiate that first term, we get x squared. Second term, we get negative 4x, and then plus 3. And then usually it's a good idea to try to factor this first derivative right away. All right, and it factors nice. X minus 1, x minus 3. So think of two numbers that multiply together to give you positive 3 that also add up to negative 4. So negative 1 and negative 3 do just that. All right, so then how do we find our critical numbers? Well, we want to look for two possible things, either where the derivative is 0 or where that derivative does not exist. All right, so derivative not existing. This is one of those things where we don't see it too often, but it does happen. And when we have a formula, we're really looking to see, do we ever have division by 0? And in this case, there's no division, so we're not going to get any critical numbers this way. All right, so what about probably the more common way that we're seeing, f prime equal to 0? Well, because we have this nice and factored, we can set each of those individual factors equal to 0. And then if we solve, we get x equals 1 and x equals 3. So these are the critical numbers. And, all right, so we found them. So now we need to classify these, and we don't know, is x equal 1? Are we going to have a min there? Are we going to have a max there? Or are we going to have neither? Same thing with x equals 3. So we don't know exactly what's happening. We just know something special could happen here. So now our next step is to actually classify. And for this, we're going to use our first derivative test. All right, so how does our first derivative test work? Well, this is basically just doing the intervals of increase, decrease. So we'll draw our number line. So we draw our x-axis. We're going to plot the critical numbers that we found. So we got x equals 1 and then 3. And again, those are just slicing up our x-axis. So we want to figure out ultimately what f prime is doing on each of those intervals, and that'll tell us what the original function f is doing on each of those intervals. And to help us with this, let's use these factors, the individual factors. So we've got the x minus 1 and the x minus 3. And when we go to fill in our sign chart here, we're going to just use test numbers. So for the first interval, we just want something less than 1, so maybe 0. And we just plug it into both of those factors. So we get 0 minus 1, which is negative, and then we get 0 minus 3, which is also negative. So we get negative, negative, and then a double negative becomes positive, which means our original function is increasing on that section. So then we go to our next interval. So we want a test number somewhere in between 1 and 3. So keep it easy. 2 is good. Plug it into both factors. 2 minus 1 is positive. 2 minus 3, negative. So we get a positive number and then a negative. And when we multiply a positive and a negative together, the result is negative. And when f prime is negative, that means the original function decreasing. All right, so then we go to our last interval. Just want something bigger than 3, so 4 is always fine. Plug it in, and we get 4 minus 1, which is positive, and then 4 minus 3, positive. So two positives multiplied together give us a positive, and when f prime is positive, that means our original function is going to be increasing. All right, so far this is just review of finding the intervals of increase, decrease. So where does the first derivative test come in? How do we actually classify these critical numbers? Well, we want to look at each critical number on our sign chart here. So we found x equals 1, x equals 3. And what we want to look at is how does the sign change going from one side to the other side right at that critical number. So if we're looking at x equals 1, we go from positive to negative. So we go from positive on one side to negative on the other side. And you could just remember that that means that we're going to have a max. But I think it's maybe a little bit easier to remember if you just kind of draw in what the graph is going to look like there. So let's try to sketch what f is going to look like. So if we start, we're going to start off increasing. Then our graph is going to flatten out, and then it's going to switch to decreasing. And, well, that's what our function is going to look like right around x equals 1. And when you draw that in, it looks like a max, and that's what the test says. Now, if we keep going, what's going to happen at x equals 3? Well, at x equals 3, if we look on our sign chart, we see that we're going from negative to positive. Now, you could just remember that that means we're going to have a minimum, which we are. But again, I think it's easier if you just kind of draw the graph. So let's keep drawing our graph here. So we're decreasing, and then our graph flattens out, and then it switches to increasing. So a rough sketch of what this function would look like, it's going to look something like this. And at x equals 3, it looks like we have a low point, and that's what our first derivative test says. We have a min. All right, so what we found is that we have a local min at x equals 1, or a local max at x equals 1, and then a local min at x equals 3. Now, so let's write that out. So x equals 1, we found, is giving us a local max. And x equals 3, we found, is giving us a local min. So we're able to classify these critical numbers. Now, the directions here actually are asking for a bit more. So it's asking us to find the value of our function. So find the local max and the local min value. So we were able to classify, and we were able to say that the local max happens at x equals 1. But when we see this word, find the local min value or the local max value, this is really talking about the value of our function. So kind of as a last step for this, we just want to make sure we actually answer the question. So when we see this word values, it means, well, evaluate the original function. All right, so our local max value is going to be our function value evaluated at x equals 1. And we know that this local max value is happening at x equals 1. So we're going to take x equals 1, and we're just going to plug it into our original function. So when we do that, we're going to get 1/3 times 1 cubed, so just 1/3. And then we're going to get -2 times 1 squared. So powers of 1 are just 1. So we're going to end up with -2 plus 3 plus 1. So that's +2, and then we'll have a plus 1/3. And if we get a common denominator here, 2 plus 1/3 is 7/3. All right, so that's our local max value. Now what about our local min value? Well, we're going to do the same thing, but we're just going to plug 3 into our function. So we know the local min is happening at x equals 3, so we're just going to plug 3 into our original function. And when we do that, let's see what we get. So wherever we see an x, we're going to switch that out with a 3. And this 3 cubed is 27, and when we divide that by 3, we're going to get 9. So this first term is just going to be +9. Then we're going to have another +9 over here. So we have 2 copies of +9. And then we're going to be subtracting 2 copies of 9. So all of this stuff is just going to cancel off. And we're just going to be left with +1. All right. And that's our local min value. So we just want to make sure we actually answer the question. I wanted the values of our function. All right, so we'll get a little more practice of this, and we'll see you in class. Bye-bye.